starting off with Chapter 14, or wireless networking. On the Comptia Network Plus exam, when we're referring to wireless networking, we're referring to the 802.11 or the Wi-Fi standard. To build a network, a wireless network, we have a few requirements. The first requirement is a wireless network interface card, or wireless NIC. This is usually built into modern day systems. Cell phones, laptops, even desktop PCs have these built in. If they're not built in, you're going to need something like a USB wireless adapter, or a PCI card that supports wireless. Again, most modern systems that have been built in the last several years, this comes built in. The only time you need to change that is if you're changing your wireless standard. Your wireless access point, you'll see it abbreviated in books as either WAP or AP. I go back and forth between the two. Kind of depends on where I am. So if you see WAP or AP, then we're just referring to the wireless access point. This wireless access point is a layer 1 device. It operates as a wireless hub. There are different types and models of these access points on the market. Many companies like Cisco or Aruba, they built straight access points, and that's all they do is serve wireless networking. Companies like D-Link, Netgear, and Linksys, they'll combine their wireless access points with switches, routers, and they'll add security features into the system. You'll also need some software on the PC or the device that's going to connect to the wireless network, and that going to consist of drivers for the network interface card, along with some kind of a configuration utility, something that checks for signal strength, your link state, networking features, etc. When designing the wireless, or when talking wireless, we have a range of items we have to talk about or become familiar with. The first one is range. The range varies according to many environmental and vendor factors. So when we talk about environmental factors, what kind of walls do you have to penetrate? Are you using a 2.4 or 5 gigahertz wireless networking? There's a lot of metal and steel. How about the interference from things like microwaves and cell phones? So the range can vary quite a bit depending on numerous factors in the wireless network. Your BSSID, or the Basic Service Set ID, this is your most basic infrastructure mode. And the BSSID is based on the MAC address of the access point. Your service set identifier is what most people are familiar with. This is basically the name of the wireless network. It's a 32-bit identity string. Or it can be up to 32 bits. And if multiple access points share the same, if you have multiple access points in the same network, they must all share the same service set identifier. So in corporate networks, you may get a building that has multiple access points. They may have 10, 20, 50, 100 access points. And since they're all part of the same network, all those access points must have the same server set identifier. And access points use an SSID broadcast to advertise the SSID. The extended service set ID, or ESSID, this is every access point that connects to a single switch becomes part of a single broadcast domain. With multiple access points in a single network, your client will connect to the access point with the strongest signal. So, and as the client moves from building to building, the device will actually move from access point to access point. And when the process of a client moving from one access point to another is called roaming. There are two frequencies used in the 802.11 wireless networks. The first one is at 2.4 gigahertz. Now, the advantages of 2.4, it's better able to penetrate walls. And one of the disadvantages is there's much more interference at this level. Microwaves, the old style portable cell phones, just a lot of devices that are in this unlicensed 2.4 gigahertz range. And the other thing is there are only 3 non-overlapping channels. And those channels are 1, 6, and 11. Now this is less able to penetrate walls. But it has much less interference. So again, there's just not as many devices in here. Microwaves operate at 2.4. Those old style wireless phones operated at 2.4. Some of those walkie-talkies may be 2.4 gigahertz. There's a lot of things at 2.4. Baby monitors, a lot of things operate at 2.4. There's just not that much at 5. And with 5 gigahertz, the FCC keeps adding bandwidth in this area, there are many more non-overlapping channels. Again, with 2.4, there's only 11 channels. With 5, we're up to about 40 channels on 5, and there's just a whole lot more that are not overlapping. So in our wireless network, we have some basic methods for broadcasting. The first one is a direct sequence spread spectrum. Or DSSS. DSSS, or direct sequence spread spectrum, that's actually used by the older 2.4 gigahertz systems, the old 802.11, 802.11b. The second one, just be aware of it, is the frequency hopping spread spectrum, or FHSS. Again, this isn't used in modern 802.11 networks, and not even used in old 802.11 networks. And this one, I hate trying to pronounce this. It's orthogonal frequency division multiplexing. This is actually used in all modern day wireless 802.11 networks. And again, OFDM is used in all modern day networks. This device here is in 802.11, the very first 802.11, and 802.11b. So again, let's just rehash this again. 2.4 gigahertz. We have channels 1 through 11. The non-overlapping channels are 1, 6, and 11. And the channels are 20 megahertz each. With the 5 gigahertz networks, we have 40 different channels. And they automatically channel switch. Basically, with the automatic channel switching, we don't have to select our the channel used by our devices. All right. Remember early on in our networking discussion, we talked about different methods for accessing our transmission media. Token ring, we talked about passing a token, and in Ethernet, we talked about carrier sense, multiple access, collision detection. In wireless, we also have a way of accessing our media, which is air. In this case, it's called carrier sense, multiple access, collision avoidance. Remember, carrier sense, we have to sense the carrier, making sure nothing's out there. Multiple access, you're going to have multiple devices, cell phones, laptops, even printers, accessing this media. But here we go to collision avoidance. Now there are two methods defined in 802.11 for CSMA-CA. The first is the one actually in use, is distributed avoidance, distributed coordination function, DCF. This is actually the one in use. The second method we don't use is point coordination function. And this is not used. So just keep that in mind. We have two of them here, one's used, one's not. So again, we use DCF, that's the one. We don't use PCF, so DCF is the one we're going to want. You'll want to memorize or for any exams. So how does collision avoidance work? So collision avoidance, this is one of those situations where it just helps to have a diagram. So we have our sender. It's going to sense our network. So again, we sense the network. Again, remember this is carrier sense, multiple access, collision avoidance. So it's got to sense the network, carrier sense. Then it asks the question, is it busy? If the answer is yes, we have a backoff routine we run. And we go back up here to the sense portion of the network. Your backoff time is equal to your interframe gap plus a random time. If the answer is no, we don't see a busy network, we're going to transmit our data. And then we wait for an acknowledgement. And we're looking for an acknowledgement here. If the acknowledgement is received, we end. If it's not received, we go back up to here. Now the receiver of the data, of our data, as we're transmitting to something, it's got to receive data. So remember, this is our sender, our receive data, and then we send an acknowledgement. So that's kind of how it works. The sender senses the network. Is it busy? If the answer is yes, we back off. We sense the network again. If it's not busy, we transmit our data. From the transmission, we're going to wait for acknowledgement. So when we transmit the data, our receiver, if it hopefully it receives the data, so we're going to have a little dash line in there, it receives the data, and then it sends an acknowledgement. If for some reason it doesn't receive the data, maybe the client's offline or there's some interference, we're going to wait for this acknowledgement down here. Again, if the receivers, we don't receive the acknowledgement, we go back up here and ask, is the network busy, and the process starts over. If we receive the data, that's awesome, and we just end the transmission. I'm going to stop here on this video. It's going to be kind of a short one.